Well, hi, good morning, and thanks so much for joining me in my shop for what could be the last video on alignment on this radio, but I wouldn't bet on that. I learned a long time ago that the alignment stage is something you probably have to run through a number of times for various reasons, and not necessarily because the first time you try to align the radio you get it wrong. It's more because you get it wrong, or there's things wrong with the radio you haven't realized yet until you start doing the alignment. So this is why when I'm doing radio repair, I spend a long time doing the alignments, because it's still part of the repair process. But that may be over now. I may have succeeded in getting rid of everything that's wrong with this radio, seriously wrong, and so it may be kind of a straight through thing, doing the alignment. I don't know. Never done it before on this radio, so we're going to find out. We'll take a look at the alignment instructions. I'll read through the remaining instructions quickly, because so I don't get caught and have to know something lower down in the alignment instructions that has an impact on what's going on higher up in the instructions. So we just want to be sure of that. First band we're going to align is band 2 at 15 megahertz. Just to start off, trying to throw me off. So here's the number 15 written right here. But the little square for it is actually quite a ways off to the side, way over here. You know, if you don't really look for these little markers and you just rely on these numbers, good luck, because I'd end up with the pointer here, and it really should be way over here for the alignment. So I think what they're trying to do is they're trying to make the front of the radio look nice by spacing out all the numbers kind of equally or evenly as much as they can, because the scales are not linear, right? So, and this one's way out of linearity, as I remember. It was very expanded here and then compressed on this side. So that's another trick they use to make the radio look nice and all that kind of stuff. It's really, see, here's another one. They got the number written here, but the box for it is over here. So you can just go wrong in so many ways. This is going to start on 15. I should get the radio switched on. That's what I should do. Just checking everything to make sure it's all is safe and ready to go. Turn the radio on, and we'll turn this power on. So we're still on the AM band. First thing we'll do is we'll switch up to the top band here. Listen to how that goes. Oh, wrong way. Well, I guess that's a good sign. So I have my signal generator already running at 15 megahertz, and I have it hooked up to the antenna. Yes, you can see, I didn't point this out. To do these alignments, the instructions include, let me turn this down because something's not working so good there. Include putting capacitors onto the antenna connection, making a little network there. And the network changes as you change bands. So I have both capacitor networks ready to go up here. I just have to move this clip lead from here to there to get to the two different band networks. I wanted that to be out of the way, so to speak. Now what's going on with the radio? So I now have a fairly small, this would be a small signal. Some radios might not even pick this up. And including this one. Let's see. Still picking it up. Now I noticed that the radio is quiet here, and as I tune it in, a hum comes with it. I'm not sure what to make of that. Can you hear the pulling? Now I'm the one turning the knob here, so you don't have that ability to really be conscious of what's happening to the knob. But as I tune across, when I get close to the station, there's a pulling. Right there. Let's go the other way. Tune it down. So moving down this way, I don't hear it pull in, but on the way out it holds and then releases. So what's happening there is a local oscillator is being fooled around with by the signal from the antenna. I think that's what's going on. So, but the signal's good, or that could just be, that could be ADC activating just after the fact, making me think all these things. That's probably what it really is. Oh no, that's definitely. Yeah, it's definitely pulling in onto the station. Doesn't sound like a terrible thing, really. Okay, and where is it coming out? So there's a little bit of wiggle room here in the control. Right on 15. You can really hear it there, the pull in. Yep. So I don't know what to make of that. It could be an artifact of the tubes that are being used. It's just a fact that the mixer tube and the way the oscillator operates, this is just a factor in this radio. I don't know. But it won't trouble us now. This is right on the money. So oscillator wise, I don't think I should do anything. What I really need to do is the RF and the antenna. Let's look at the instructions here for a second. Let's turn down the radio a bit here. What does this tell us? So the step we are on right now is this one, step number 9. Connected the dummy antenna, running at 15 megahertz. We're on band 2. Band 2. We're aiming for the oscillator slug. I just said it looks like it's right on 15. No need to do the oscillator slug. Next one would be dummy antenna. Now we go to 4.8. Why do we do that? I don't know. Why switch down a couple kilohertz here? But we do. It seems to be consistent how this is always done. So somebody knows, I don't. RF and antenna slugs. So to do these, I have to pop out a section to get at the RF slug. RF slug is next in the list. 14.8. Okay, I think we can do it. Oh, one last thing. The number 2 slug is identified. Whoops, let's try this. Oh, I don't know. Number 2 slug. Down here. Number 2 slug. Just to be absolutely sure. Right, this isn't the right thing, is it? Coil strip markings. Band number 2 is marked 14L. I gotta look for 14L. That's the band range. Yep, 14 to 15.7. So 14L. It's 14L. I have to pull that out. I don't want to be turning this radio on and off and on and off and on and off, but I think I can get those slugs out of there. And with it operating, I should be able to. And the slug I'm pulling out is not part of the circuit. Okay, 14L. There's 14L. Okay, 14L is this one. Let's see if we can get it out of there. Find a nice, easy, trouble-free technique for doing this. Okay, we go back to band 2, and as I said before, I don't even know how this can operate. This is coming loose. Oh my gosh, this is coming loose again. What the heck is going on with these set screws? I don't know how much tighter I can crank them. I said geez because it was like a quarter turn off. It's completely loose. Gee, loose right off, right off. Oh my gosh. Bend my tool. Yeah, well, anyway. Might be something that has to be done very regularly. It's, that's got to be a problem with all these radios, too. Why? Ooh. That doesn't sound very good at all. What gives? Where are we? We're on band. Apologize for that. Band 1, band 2. Where's the sound? Oh, I took them. Right. The radio can't work with this. Well, what am I supposed to do now to try to align this thing? Crank up the signal from the signal generator. Oh, it's still there. It's not in the right spot anymore. Move spots. So what's that mean? Is that So you're supposed to remove this section to perform the RF alignment. Appears to have caused the radio to retune. Now what am I supposed to do? I'm supposed to try to peak this. Like, what am I supposed to do? I will do what I have been doing, because I'm not doing an oscillator. It's not a tuning issue. I'll just tune the radio so it's receiving as strong as it can, and then I'll adjust it to peak that up. I don't know what else to do here, really. Stop at every turn. Where'd that hum come from anyway? Something happened when I was fooling around over here. Something changed, and well, we'll assume the hum is because this piece is out. It doesn't make any sense to me, but let's carry on. Maybe we're encountering another problem with the radio. Okay, what's with my meter here today? We need a little more signal to do this. There we go. I'm in the slug. Watch the meter. Wow, is that ever distinct? I'm worried that there's noise in there that we're tuning around. Nope. Just this really ugly hum. What has happened? Oh, microphonic tube. Is it that crazy antenna connection? I'm wiggling the AM antenna connection here. No. I don't know where the hum came from. Couldn't tell you. Let's get stronger up here. So 14.7 on there. This is 15.6. That's 900. That's double the IF. That's the image. On this band, on this band, where's the local oscillator? On this band, the local oscillator. I'm just going to take a peek here at the manual. The local oscillator is where? Oh, for crying out loud. I tried to memorize this, but obviously I didn't succeed. Local oscillator is higher than the target frequency on 1, 7, and 8. So everything else, okay, so that I can remember it now. 1, 7, and 8, everything else in the middle is lower than the signal frequency. So that means we tune here, local oscillator, whoops. What does that mean? What does that mean? It means if we are feeding in a 14 signal, so let's tune this where the signal is, because I'm losing my mind here trying to explain this. It's way up here. Actually, it sounds better, but it doesn't sound as loud. So we're finding the image up here, but the local oscillator is supposed to be down here. The image should be down here. So what we're finding up here is a curious thing, or have I got this all turned around? Let me read again. Local oscillator frequency is higher than the signal frequency on bands 1, 7, and 8. Those are the outside bands. The local oscillator is lower than the signal frequency on all other bands. The local oscillator. We're going to have to find out where the local oscillator actually is on this band before we start fiddling around further, because it looks to me like it's been aligned backwards. Okay, so let me set up and get the SDR radio going and all that kind of stuff. You can see I have the antenna at the ready here already, the antenna pickup coil. Okay, so I'm going to show you the SDR output, just because this image is going to be gone. You're just going to look at the SDR on the screen here in a sec. This is the pickup coil. There's no direct connection into the radio at all. It's just whatever radiation is coming out of the radio frequency radiation, picked up by the coil, fed into my SDR. We're going to look at it on the screen. And then we're going to scratch our heads big time. Okay, so what's on the SDR screen here? So you see quite a few signals. Let's see, the radio is tuned to 14.7. So if the local oscillator is below, the local oscillator should be around 13. No, 14.3. 14.3. 14.3. So I'm gonna stick. Where would 14.3 be? Right there. So we're looking for an oscillator frequency right around this area here. If it's been done wrong, then it's going to be way up here somewhere. But here's what now, to identify which one of those is a local oscillator, I'll tune the radio. That'll vary the local oscillator frequency. And watch what happens now. So I'm just rotating it back and forth slowly. You can hear it as it tunes through. We get just a lovely display on the SDR. Let me just keep tuning until all those things, they look like they're going to come together. Right there. So what's happening on my SDR now, and what's happening in the radio, and why am I seeing these things on the SDR? I don't have a good answer for this. This is something that is showing up the whole time I've tried SDR, using an SDR radio to do this kind of work. This one's particularly annoying because, so which one of those is the local oscillator? Are any of them the local oscillator? Holy smokes. How much of that is actually in the radio, actually being produced by the radio? How much of that is just the SDR? And see, normally you're not tuning in frequencies that are wandering around, right? You're tuning in fixed stations. So just wait 1 second. So if you tuned it in, you'd see this, and you go, oh, guess those are all stations. If one of them began to vary in frequency, you might start seeing stuff like this on your SDR, but you never will because the transmitted stations don't wander around like this. This is what I've kind of discovered. It's so bad, I have another SDR, I'll suddenly get a AM radio station in the middle of nowhere, like out in the middle of short wave band. Clear as a bell too. Very strange. Shortwave station showing up way out of band, but they aren't. They're just ghosty things. So you're going to try this with your SDR. Good luck. Now, what can we do with this while it's behaving this way? We can still get away with something here. So first we'll figure out what exactly the local oscillator should be. To do that, I'm going to pick some simple places to tune. I'm going to tune to 15 megahertz. So the dial pointer is on 15 megahertz. Okay. And I'm going to vary the oscillator, my signal oscillator here. So you can hear it passing through the tune point, and it matches up. So if we're listening to 15 and the local oscillator is 455 below it, the local oscillator should be at 14,545. 14,545. Did I get that right? 14. I think I did. 5. Maybe not. The red line is where the local oscillator should be. The strongest signal I see is this one way down here. And there is one right here. Now let's think about this too. As I tune the radio up band, the local oscillator should go up band. So I'm going to tune the radio up, and one of those lines has got to move up. And I'm wondering if this one, because I think all the ones up here move down, and it's just some screwball thing going on here. Okay, so I'm going to tune up. There we go. Who's going up with me? Okay, so I see the line just to the right of the red going up. I'll bring it back down. Lots of weird stuff in there, eh? So I'm going to put that right on the red line. So the local oscillator is sitting on the red line. Now, the local oscillator is not normally modulated, but let's listen to the SDR. Holy smokes! The situation gets stranger and stranger. Now let me tune the SDR a bit just to be sure of this. What is that? So I'll tune the radio to move the local oscillator. And put it back. Oh my gosh. Well, this is something new. You know, I've never, you know, I use the SDR to find the local oscillator, as weird as it is this time. I've never tried listening to it. Why would you want to listen to it? Local oscillator should be an unmodulated signal. It shouldn't have any sound coming out of a radio like this. I'm not sure what to make of that. You know, it's just another one of those things I'm going to note for further research. Now let's get to aligning the radio. And is this proven that the local oscillator is where it should be? I kind of think it has. Because we are finding it around the proper frequency. We're finding a line on the SDR around the proper frequency. Now we want to force things. So how are we going to do that? So I'm going to set the radio on 15. You can hear the tone coming out of it here. I'll turn it up briefly. Right? It'll shut the sound off on the SDR, so we're not listening to that. The local oscillator with a 455 IF must be at 455 below 15. 455 below 15 is 14. So 455, that's 14, 545. 545. So that's where the red line is. But look where the local oscillator is. How does this work out? How can this be? I'm not quite on 15 on the signal generator. Let me move it to exactly 15. I think maybe this is part of the problem here. We're just a little off 15. Okay, so we're about as dead on as I can get. Hardly any different. Tune the radio. Oh. Okay, so now the pointer is off the 15 mark slightly. The local oscillator frequency now. Let me put it right on the red line. You know, you couldn't even see, well, you could maybe now, how much I turned the tuning knob. It's a very, very minor amount. So now I'm just going to check that with a signal generator and see what frequency we're on. No, I can't really get much closer to 15 here. We're sending at 15, we're hearing 15, local oscillator is set now for 15 properly. So what's wrong is the dial setting. The dial is off, the pointer is off, the pointer is off. Is that what that means? Is that what this means? Is that what this means? Pointer is off, pointer is off. So the interesting thing, let me just revert back here. So here's the dot, and here's the number, and 15 is falling kind of in the middle. So I think a safe assumption is this radio was only aligned originally in the factory. They wouldn't have made a mistake in the factory. They would have got it right for sure. They would have done it here. So let's just change the oscillator setting now. I'm going to leave the pointer where it is. Or has the pointer wandered? Oh no. Let's go down and check. Don't have to check at one end. No, it's exactly where it was. Back on 15. Just touch my signal generator frequency slightly. trying to adjust 1 in 15 million here. That's pretty tough. It just doesn't want to sit on 15. It's jumping around it. Okay, got it. By Jove, I got it. Oh, wait a minute, I took the strip out and the radio retuned. I should put the strip back in. I should complete the alignment per the instructions, put the strip back in and see if this goes back to where it should be. I'm ready to put the strip back in anyway, aren't I? So we tune off to get the signal. Okay, so I'm not exactly sure how to approach this problem, but let's just keep working away at it. I think sooner or later it'll all come clear. Pretty clear I'm not going to do all the bands today, not at this rate. Not at this rate. Okay, so I'm in the slug. I'm watching the meter now. Boy, does that ever seem like a oscillator. I think I'm getting oscillator pull-in here. I don't know. It's so watch. I'll set this right here. Tune to the max. Too much signal, too much ABC coming in here. So that's maxed with the RF. If I tune it off with the RF and then tune the dial, I don't know what to think now. So I get a peak at this setting. That does kind of make sense, you know. This is the rock the tuning dial issue, I believe. You know, there's play in the tuning dial. Let's look at the SDR and just see what happened to the frequency here. So we see we're a little off up here now. So let me put it back on. It's got to be on this. Let's adjust with the yeah, right. No, I don't want to do that. Oh my god, I almost adjusted the oscillator again. I keep forgetting. I think it's in a weird situation with the strip out. So so just leave it. God help me, I'm totally spun around in circles here. Okay, I'm gonna pop the strip back in and just see what we got going here, because I kind of lost a little bit. I'll bring down the. Okay, sometimes distractions come at the worst time. Now that little sound you just heard, that was a light being switched on in the room next to me with a dimmer. Actually, it was the automatic dimming light in the room next to me going off, is what that was. So as simple and easy as this is, it's not. There we go. I got it. Well, I didn't get it. Let's straighten it out. There. Woo! Okay. Okay, let's go see what happened now with this radio. I still have another adjustment to make, but let's see what happened to the frequency. Signal generator on 15. Oh, for crying out loud, I'm on another band, right? I didn't switch it back to the band. And whoop, whoop, don't do that. Okay. Band 2. There we are. I feel better now. Oh, yeah. Oh, way louder. Way louder. Okay, so now we're feeding quite a low signal into the radio. Oh, it's very sensitive. You still hear that? You can definitely hear the pull-in. Not necessarily a terrible thing. There's a noise there, and the signal. Let's move it up a bit to this. Let me move it a bit. Where'd the noise go? The noise is gone, so the noise wasn't really there. Well, there is something there. One more adjustment, and then we'll put an antenna on it. I think this is going to be a band a day at this rate. Okay, next to the last adjustment. The last adjustment is the last adjustment on this band. So we tuned to 14.8. We've done the RF. We've put back in the antenna slug, the antenna section. So this is what's left. Antenna slug, 14.8. Oh, why 14.8? Okay, we'll do that. 14.8. That's about as good as I can get it there. 14.8. There it is. That terrible hum that comes in. I wonder if that leaky 1L6 is the reason for the hum. Let's find out. Let's find out. What did I do with my good 1L6? Oh no. No, I've gone and put it somewhere. Where did I put it? Right here. Right here. Right here. Okay, 1L6 is up on top of the I think it's this one here. So I put tape around it to mark it. I wrote the word leak on it even, so I can't get messed up. Well, I can still get messed up. I'm sure I can find a way. Okay, so this is the non-leaky, only good 1L6 I appear to have. And this cover never goes on right. Everybody ready? Now, watch this. The whole radio works differently now. Yeah, I just did a tube. Shouldn't be really a problem here. Still there, right? Interesting enough, when you get it tuned right in, the hum seems to disappear. Something in the sidebands of the signal? That doesn't make sense to me. I think it's an effect of one of the tubes or something. Okay, we'll carry on. Nothing else really changed though, eh? Interesting enough. So where are we now? We should be at 14.8. 14.7585. I think 14.8 would be about there. Well, we're gonna put it where it's maxed. I wonder if we can see the local oscillator pull in on the SDR if I set it up right. Let's try that little experiment. I'm going to tune this here. I'm going to flip up the SDR on the screen again. And so what I'm going to do is I'm going to zoom in. I'm not sure which. I think this is the right one here. I'm going to zoom in on it. Let's put the red line. 455. Let's put the red line here because the radio zooms in on the red line. Here we go. Or the software does. Now I'm going to tune the radio. Some of these lines are going to move, and what we're looking for is a kind of a jump in. Let's see if I got it on the screen yet. Do you see that? See that jump? Now, what you hear and what you see are two different things. The reason being, there's a delay on the SDR. The SDR comes after what you hear. So what I'll do, I'll tune up a little higher here. I'm just going to tune steady across, and the waterfall display will reveal the truth. Here we go. Steady across. Jumped already. Hanging on. Hanging on. Hanging on. Doesn't really seem to jump away, but come back, steady. See if it jumps in. Steady. Okay, no jumping in. Jump out. Look at that. A huge jump out. Interesting stuff. You know, better and better radios have fewer and fewer of these kinds of problems. Surprising in a way that this one would have this problem, though. The main thing is, in my mind, it's pulling in. It's actually tuning in to where you're going anyway. So, is this really a problem of some concern? Maybe not. Interesting to me how that pulls in one direction, but not the other. So where are we here? We're back here. Oh, now I got a cat calling for me. Yes, sirree, my buddy cat. What do you want? What are you looking for? Want to come in? See, that was it. When he looked the other way, he's telling me, no, I want to go over there. Well, Peanut, I still have some brain cells left here to burn off this morning, so just hang on. It'll only take like another 5 or 10 minutes. Sorry, buddy. So there's still some wacko problems in here. I gotta tune in some real radio stations. Is there a chance we can get WWV right now? Let's give it a try. So to do that, I have this crazy antenna attached to the back of the radio here. Antenna coupling. gizmo, but I think I can bypass all this. But I'll take this off. Okay, take this off too. Now, this is my outdoor antenna, but it may not be switched down here. Clip it on the ground. I have my choice where to clip it now. I'm going to clip it. You see all these capacitors? Never mind. I'm going to bypass them all. You know what? There's a capacitor shorting this out. That's not going to work. Something like that. I don't want that. I don't want that. I want it more like this. Okay. Outdoor antenna is connected. 10:20 in the morning. Speed of the devil. I have to go throw an antenna switch, and I'll be back. Okay, no need to throw the switch. It was already thrown. So there we are. That's not too bad. 15. It's just about dead on, too. Now let's see if we can make this stronger. Because I can still do one adjustment here. It's the antenna adjustment with a real antenna on it. Here we go. It's fading now. At the tone. I can barely hear his voice. The other RF strip now is not accessible. That's pretty good reception, actually. Let's go see what else we can find here. Should be a strong signal up at 15770 if we can get that. Cuban signal. Good. Yeah, so I hear a humming now. I hear his voice is warbly. Goes up and down with the AVC, it seems. More warble, less warble. So when the AVC is weak, the signal sounds clearer. When the AVC gets strong, the signal gets that garble. There. I like Indian music. No copyright hits here in North America. There's the pull-in and the strong hum. Now you really hear how bad it is. Yeah. Well, I think all I've really found at this point is there's another problem in this radio that has to be resolved. And it's this hum that's, to me, being conveyed through the AVC somehow. It's interesting. One of my mentors phoned me up the other day and said, "Hey Jim, what do you do about a radio that hums when you tune stuff in?" And we had a chit chat about that. And I told him in the end, probably what it is when you have a signal being detected in the detector and the diode is doing its job, that the problems with the diode get conveyed on in the sound of the radio and back through the AVC of the radio. There's something going on there with the detector. And what would be going on? The heaters in the radio, like most radios. I was going to say something's not true. I was going to say the heaters run with the AC, but they aren't in this radio. They don't run with AC in this radio. See, I think the AVC is relaxed enough now. We don't hear any hum. So my thinking, anyway, just to continue on with my thinking before, the AC powering the heater is causing the hum that he was hearing in his radio, only there when the signal is utilizing the diode in the detector. And I've heard lots of radios like this myself. Never bad enough to worry about. This one's pretty bad. So something is modulating the IF signal in some way. Is that another way of viewing this? So with just noise in that coming through, you don't really hear that. But when you get a signal coming through the IF begins to work hard. Its problems come along with it. Maybe that's a way of looking at it. So I don't hear it at all. Maybe because the signal's so weak. And is that the 5770? That's a strong one there. Let's see what frequency that is. $15,700, I think. It's right on the $15,700 setting there too. Almost. That's the signal generator where it's at. I think what I'm going to do is I'm going to stop at this point. I was hoping to do all the bands this morning. Wow, Mr. Optimism. I'm going to stop at this point because I have some things here to think about and make some decisions around whether to continue forward with more alignment work and see what happens on the rest of the bands, which is a valid thing to do. Go after this hum thing. I'm not sure how to go after it. Except that, hey, this is the way the radio works. This is as good as she gets. And in fact, I should be pretty happy. Finish the alignment, back it up, put it in the box, get another radio. So I got some decisions to make about that. The actual sensitivity of the radio is very good now, at least on this band. Yeah, I'm going to go think about all this. There's just too many things have come up here all at once. I should give it some time to think about what I want to do next instead of jumping into something. Thanks a lot for watching, and slowly, step by step, the radio's coming back to life.